So, can you see an analog? Can you spot the differences and analog between the both formulas?
Yes, sir.
What? One of the thing is that okay, you should have which is like AQ,
Minus
It's like from B to A, so it's like Q to not P but P plus 1. So it's like this guy is like this difference. So you can see you don't have a minus here actually. You don't have a minus here. While you have this one is positive. But you can see that here you have Bn and Bn plus 1. Let's say. So if I take minus out, I'm going to have minus and Bn plus 1 minus. So it is really analog of that. But just tell me that what is the playing in this sum? What is the playing the role of U?
A plus.
And V. What is V and what is DU and what is DV? Roughly, just give me. Because if I compare this sum with this, okay, there must be something U and something DV. And if I compare with this, then I should have V minus. No, this is analog of this term. This is analog of this term. So if we can it should be alive. U and it should be in that.
So here's a sequence. U sequence will be A. U sequence will be A.
Which A, bigger capital N or smaller n?
Similar A.
I
Small and small.
Similar
okay, let's take U to be smaller a n. So what should be the V then?
DV or first DV then D.
The V. This is the thing. That's what I'm asking that. I'm saying that I have these two formulas, and I'm saying that that's a continuous time form of this actually. So that if I take limit on this, I'm going to have this roughly. Okay, anyway, so let's try to spot.
Sir. T is capital A.
Let's take V to be capital A. What is going to be the DV then? DV is going to be A
Small
n.
n.
Just think about it. So it's like you are taking A n plus 1 n. A n, you take the difference, you're going to have.
Summation out.
You're going to have small a n. Now DV is going to be like A n. And for you, I don't have any option then.
BN.
B.
Yeah.
That is D.
And U is going to be n plus 1 minus B n. Roughly. Is it going to take like so if I'm saying that I have this sum A and B n, so I have U times A n which is dV, so it's like a U dV, okay, equal to UV. So what is U my? B. So my U is capital A n and my V is,
So your V is capital A N.
so this is dV actually.
DV.
So it's like a U dV.
DV.
Minus, and then I have a UV and just substituting the limits. Okay, so it's like E to Q. So it's like a UV evaluated at
Q minus Q.
Q and UV
Evaluated.
evaluated at not P but P minus 1. Just missing it, huh? Just missing. ठीक है? Put it as a standstill. Huh? What about without?
So first is from the
Just think about it.
first.
I'm saying that take U to be Bn, then du is going to be what? Just like difference of two instant. So roughly I can interpret it as Bn plus 1 minus Bn, for example. And my V is An, then what is going to be my dV? So it's going to be roughly An plus 1 minus An, which is smaller An actually, because An plus 1 is what? This is sum from 0 to An plus 1. Maybe An plus 1. And my An is sum from 0 to N. And you take the difference, so it's going to give you the one. So I can interpret V to be An and dV to be roughly An. So if I keep in view this, I would say that my Bn, which is uv, and my An is du. So integral v du is same as
Summation.
integral
VDU.
u dv
Plus VD.
VDU.
v du plus uv.
UV. The limits.
So u is E and V is here, and evaluated at from the limits of A to B, so area of P to Q. So you need to be careful. It's not going to be exactly P to Q.
P minus 1.
Okay. Let's try to see geometrically that what is going on. So geometrically it has a very beautiful meaning. Okay. Proof is simple algebra. Yourself. This simple algebra. So it's like just expand this side, substitute value here, expand this side is going to be equal to this side. Just substitute An here, AQ, VQ here, simplify, and everything will turn out to be this. So the right proof is very easy, just a one-liner proof, see from both. Okay. So I just want to give you a pictorial meaning of that, okay, what you were saying. So imagine I have a square. So it's like roughly my U axis, V axis, and An axis, Bn axis. Okay. So my A1 is like what? So it's like something like this. So that's my A1. And from this to this, I have part say A2, and A3, A4. That's enough for understanding. But, this guy, and this might, it's not only going to this one, it's going to this one. And then so geometrically, this guy is telling you that if you take B1 and multiply with A1, so you're going to have this area of rectangle. See? And if I take B2, go beyond B2 and multiply with A2, so I'm going to have area of this rectangle. And area of this rectangle, and then the final area of this rectangle. So this formula is telling you that if you take these products, it is same as that you take the whole UV and subtract out these bits. Then these bits are what? Let's think about it.
That's what again.
And these bits are what? So I'm gonna say that this bit, which is remaining, I should have used some other term. Okay. This chart is A1 and B2 minus B1 actually. So that's the right.
said.
And this part is what?
A2
A2
minus
A1 plus A2, not A2 but A1 plus A2
A2 minus
multiplied by B2 minus B3 minus B2 and so on and so forth. So you are saying that essentially, if you see this geometrically presented beautifully. Okay. This is called the summation method for you. Now, you have to do this proof algebraically yourself. Both, okay? Don't ignore that, those things especially which I said, because that you should do them yourself. Now, what is the beauty of this integral? The beauty of this integral is what? So you basically saying that you can integrate one function with respect to another function. You're not integrating with respect to line actually. Or it could be like the product rule, so integral of two functions of two. If you see here, why this is beautiful? That now you have a series, finite series, which is not just one series, but a kind of a product series formed by the product of two sequences. They say that this sum is going to be expanded like this. Is it making sense? Now using this, I'm going to prove an excellent result, Bazeka result, okay, which is going to show you that imagine you have two series. So I have a very complicated series and I want to test the convergence of that series, and you realize that okay, this series is basically product of, it can be written as a product of two series. Not series, it's not a product of two series, but it's a product of two sequences, as a series formed by the product of two sequences. Now when such series is going to converge, that's what is going to be. So in other words, if I have, for example, minus 1 raised to n divided by n,
You can write it.
I can write it as that, okay, this is product of basically two series, minus 1 times 1 over n. So the next thing I'm going to write is basically that if you have such kind of series, such can be written as in such a manner, then how you can know that whether it converges or not. Right? So it will be beautiful criteria. We have to learn this rigorously. If you want to live in this world, you have to learn this. You must go stay from that. We have to stop being lazy.
Yes, sir.
That's the part.
You go try to do that. Okay, so imagine with this notation, imagine if I say that the partial sums of an of is bounded convergence. Let's prove that partial sums are bounded. We say that P naught is bigger than G1, G2, and so forth. C condition that limit goes to infinity, 0, then series formed by such a n's and the b n is going to converge. So it's a kind of a sufficient condition for convergence for such kind of series. So imagine I have such kind of a series in which you have product of two, mostly representative is product of two sequences. Okay. And one of sequence has these properties that their partial sums are bounded and other sequence is decreasing and limit goes to 0. So if all these are true, then the series is going to be lost. Just think about it. Just think about it. Does this sequence have all these properties? This sequence that I just wrote before, minus 1 raised to n over n. So if this is the case, what should be your choice of an? So you can choose an to be 1 over n. That's not a reason. I can choose an to be minus 1 raised to power n. I have the sum an. The sum an is going to be what? It's like a minus 1 plus 1, minus 1 plus 1, minus 1 plus 1. Stop at n. So this sum is going to be
minus 1 power n minus
necessarily 0.
sir minus 1 power n.
If n, so it's like if I have only one term, maybe you have one actually, minus 1. And you have two terms, then you have minus 1 plus 1. Huh? You have 0. And if you have three terms, you will have again minus 1 and you have 0. So minus 1, 0, minus 1, 0, that's it. So this an is going to be either minus 1 or which are both bounded actually. How about bn? bn is decreasing, satisfies this property, and its nth term goes to 0. So by this test, we can say that this series converges. Very interestingly, just think about it, that if I just take 1 over n, or minus 1 over n is not going to converge actually, it's going to diverge. If you take minus 1 raised to n, just think about it, if I just have 1 over n, it's a harmonic series. Minus 1 over n is a harmonic series. Harmonic series always diverges. But this, you can speculate that this also going to diverge, but it's kind of this is going to be very interesting when you have alternating series actually. Okay, so let's take this. Let's try to prove this result, and based on this result, I'd like to do the last test of today's discussion. Right, yes. This is I'm going to do. Okay. So imagine all these functions are true, and my claim is that this must be convergent. Basically, BD. Okay. So here's the proof. So since the ANs are bounded, so there must exist a number such that absolute of A always sit between them and that. So it's like choose N such that absolute of N is less than or equal to M. Why I can choose such a M? Because this AN is capital AN is bounded up. All I'm doing is nothing. Because of the boundedness, it's because of the part A. For given epsilon positive,
Sir, bounded subterms can be greater than extends value. For all,
okay, this is true.
it should be.
For given epsilon positive, I have to write. So, in order to prove the convergence of series, what is the most basic criteria that we learned actually? What was the most basic criteria? So, we learned the Cauchy criterion.
Cauchy.
Okay. Cauchy criterion. So, in other words, if I take, for example, Sn for this sequence is going to be what? So it's going to be from 0 to n, an should be bk. Okay. And if I take Sn, instead of Sn, I'm taking Sp and Sq because we have used p's and q's there. Q is going to be sum from 0 to q and bk. So if I take the difference, this Sp minus Sq, I want an instant after that this difference must be less than epsilon is. That's what I want. Okay? Now this is equal to what? This is equal to what? So this is going to be roughly equal to the sum which starts from P and at Q. Because the rest of the terms are going to go away. Okay? I can choose index A and B and now I can apply summation by parts formula. Agree? Apply summation by parts formula. If I apply summation by parts formula, what will I have? I'm going to have sum from P Q minus 1 and An Bn minus Bn plus 1 AQ minus A P minus 1 B minus. Okay, so just substitute the values. Okay. Now just think about it. These ANs are always smaller than or equal to M actually. Okay. So I can say that this number is less than or equal to what? This sum, and I can replace here by M. And on the place of Q I can replace by M. And here I can also replace by M actually. Okay, look at the point. Everywhere I can replace things by M. Okay. So I can have M times the sum of P with Q minus 1 Bn minus Bn plus 1. Okay. Plus BQ This full 10 long term. Minus for that, I can also do BP as well. It's fine. This sum is strictly so DQ is DQ, minus is plus, and BP minus 1 is smaller than DQ. This still works out. But what would be the benefit of writing this expression in this manner? Just think about it. If I expand this sum, I'm going to have what? It's like a BP plus 1 and so on and so forth, expand it. So it's going to be kind of a telescopic sum actually.
Yes.
In which everything is going to cancel out except some terms, and those some terms are okay. I can do another thing. That another thing is that all of these terms are smaller than BQ. So this is smaller than BQ. Why? Because the sequence is increasing.
Sir,
I should be
greater.
smaller than BP actually.
Yes.
Okay, so that this is smaller than BP, this is smaller than BP, this is smaller than BP, and this is smaller than. All of these are smaller than BP. Okay. So I can do what? I can say that this guy is smaller than. Okay. 2m and BP. Okay. How can I have that? You can do one thing, expand it, okay? Terms will cancel out.
Yes.
You're going to remain with only few terms, okay? And those sum is going to be bounded by 2 terms of BP. So only 2 terms are going to survive, and each of the term is smaller than BP, so you're going to have less than or equal to, not equal to, but less than or equal to a BP. Okay? And what I want actually, so I want to, make this smaller than epsilon. How can I do it? Can I make it smaller than epsilon? I can make it. Why? Because Bn converges to 0. If this converges to 0, I can make Bn to be
Less than epsilon.
less than epsilon for all n bigger than or equal to capital N. So not only less than epsilon, but less than, say for example, 2n, epsilon by 2n, because of the convergence. So hence you're going to say that this is smaller than, this is what? Smaller than epsilon by, so going to be smaller than epsilon. This that is, need to make sure that P is, this n is because this is true, then for all n bigger than or equal to n. While here we don't have n, we have VP actually. So we have to make a choice basically. So I can take a maximum of P and capital N, and that will be my new n. And after that n, this is going to be smaller than. This is going to be smaller than. For all n bigger than or equal to maximum of P
N.
and
N.
that's what we want to do. Okay. I can quickly rewrite, explain this again. Okay. Okay. So the first condition says that n is bounded for every n. So this means that there exists n such that absolute of n is smaller than or equal to n for 1. Okay. Usually is I need to prove the convergence of this series. So what I need to do, I can apply the Cauchy test actually. Okay. Cauchy test. And that for that Cauchy test I need to take what? I need to take two partial sums, P and